Today we're looking at similar triangles, similar figures, proportional parts, and scale factor. So how do I find missing measures of similar figures is our essential question. My learning intention, I'm learning to use similar triangles to find missing measures. So we learned about the criteria to be similar. Are these triangles similar? Justify and write the similarity statement. So what we need to do is to match up our proportional sides. So if I'm looking over here, the smallest side is 48. Over here, the smallest side is 8. The next side is 72. Next side is 12. And finally, 84 and 14. So using my calculator to see what it looks like as a simplified fraction, 48 divided by 8, hit my math button, hit enter twice, and I get 6. 72 divided by 12, and I get 6 again. 84 divided by 14 gives me 6 again. So they are similar. By side, side, side. And let's see, triangle ABC is similar to triangle. Okay, from A to B is my middle part. I go middle, small, large. Middle, small, large. H, G, F. Okay, now what is my scale factor? So if I choose 48 times my scale factor is equal to 8. Divide both sides by 48. My scale factor is 8 over 48, which simplifies down to hit my math button, enter, enter, 1 over 6. So any side that I multiply by 1 over 6 will, from the first triangle, will give me the length of the corresponding side on the second triangle. Okay, what does proportional parts of similar triangle statement say? It says if two triangles are similar, then the ratio of their corresponding sides are equal. The similar is like that. Then the ratios of their corresponding sides I forgot my S. Are equal. Okay, you're told that these two triangles are similar. Find their missing measures. So if we're looking at this, what matches up? 20 matches with 12. So if I call this one X and this one Y, $20 divided by 12 is equal to 15 over X. 15 and X match up. To solve, you multiply at your diagonal and then you divide going up. 15 times 12 divided by 20 is equal to X. And we get 9. Okay, what about Y? Well, you have to start with that same fraction. Or actually, you could use the other fraction at this point. So we know that 20 over 12 is equal to 10 over Y. You multiply at that diagonal and then divide. 10 times 12 divided by 20 is equal to Y. And you end up with 6. Okay, so for the next one, these quadrilaterals are similar. Find X. So if you're looking at this, the easiest one to probably look at is 90 over 10. That means I'm dividing by 9 to get that, or multiplying by 1 over 9. 10 times what gives me 90? 10 times 9. 7 times what will give me X? So let's set it up as an equation. 90 over 10 will equal 7 over X. Multiply at your diagonal, then divide going up. 7 times 10 divided by 90 is equal to X. And that is 7 over 9. Did I get it set up right? Because the 90 and the X should be in the same spot. So this should be X over 9, or over 7. This will be 7 times 90 divided by 10. Our diagonal now is going up. Seven times 90 divided by 10 is 63, and that makes much more sense. Okay, so let's find our scale factor. 90 times our scale factor is equal to 10. Divide both sides by 90. And now our scale factor becomes, I can simplify it by dividing top and bottom by 10, becomes 1 over 9. So if you multiply by 1/9, you get the new side, and that's your scale factor. Okay, and that brings us to the definition of scale factor. So your scale factor is the multiplier used on each dimension to change one figure into the other. Now remember, the important part is the number you multiply by. So if it is getting smaller, that number you're multiplying by will be a fraction. So on the next one, find x, because the quadrilaterals are similar, find the scale factor, and then find x. So if you're looking at this, which one is the easiest to find the scale factor for? Which sides would be the easiest? Well, if I was looking at this, I'd see 10 and 40. So 10 times my scale factor is equal to 40. Divide both sides by 10, and my scale factor is 4. Okay, so I notice that 3 and x are corresponding sides. So 3 times my scale factor will give me x. 3 times 4 is equal to x. 12 is equal to x. Any questions? Okay, are these triangles similar? Justify. If they are similar, find the missing lengths. So, if you notice, I don't have enough pieces to say they're similar by side, 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 so I've got to look at my angles. I know that angle K is part of both of them. I've got parallel lines, so I know that angle KGH is going to be congruent to angle KJL. What kind of angles are they? Parallel lines, and they are corresponding. So, by angle, angle, because angle K is congruent to angle K, and angle KGH is congruent to angle KJL. These are your corresponding angles. Okay, so let's look at setting up pieces. Okay, if I want to find this piece here, 6 over 8.4 is equal to 4 over whatever. If I'm going to call that, this one here is x, so I'm going to call this y. Do you want to go top to bottom or side to side? Both work. Top to bottom, side to side. Let's go top to bottom. 6 over 4 is equal to, across from 6 is 8.4 over y. Once again, we multiply and then divide. 8.4 times 4 divided by 6. And you ended up with 5.6. Okay, now, to find x. X is the base of the whole triangle. So, 6 over x. Side over side. What is my side here? Is equal to 6 plus 4, that's my whole side, over 15. Multiply and then divide. 6 times 15 divided by, what is 6 plus 4? 10. And you end up with 9. So, when you're looking, your scale factor is that number you multiply by to get the dilated figure, to get that similar figure, the length of the ratio for the similar figures. So, how do you know you're successful? When you can use similar triangles or similar figures to find missing measures. So we did similar figures, scale factor, and what was the last thing we did? Equivalent ratios. That's what proportional means, equivalent ratios.